Okay. Hello, everyone. We want to welcome you to Holy Spirit Parish. We're so very grateful that you're here for this important conversation and discussion of extreme heat that we've all been seeing, these unrelenting heat spells, especially in the west and southwest this summer. And we're very, very grateful to Mike Staudenmaer, who was here. He arrived yesterday from Utah. He's here for a week visiting his mom, Paulette. See, where are you, Paulette? And Paulette, thank you so much for sharing him. You're used to it? Oh, no, it's really wonderful that he's taking this evening of a rather short visit. Actually, this isn't the first time Mike has participated in an environmental justice presentation. Back during Earth Week of 2021, we had a Zoom presentation where he was one of 4 panelists. He came on from Utah. The other 3 were here in town, but of course, the whole thing was on Zoom because of COVID. And it was Care for Our Earth, and each one represented from their own professions. It was interesting, you know, the Canticle of the Sun of St. Francis of Assisi. Mike represented Brother Wind. We had someone representing Sister Water and Mother Earth, and Brother Sun. Yes, Brother Sun, obviously. So, anyway, and by the way, the feast day of St. Francis of Assisi is 2 days from today, on October 4th. And maybe a little bit more about that. October 4th. Today's the 2nd, yeah. I think. So let me just tell you a little bit about Mike, and then we'll turn it over to him. Michael Staudenmaer is the chief scientist for the National Weather Service, which is an agency within the National Oceanic and Atmospheric Administration, or NOAA. Michael grew up in Wisconsin, including quite a few years on the family farm, and attended UW-Madison. Michael received a bachelor's and master's degree in atmospheric science before joining the National Weather Service in 1993. Starting as an intern in Sacramento, California, Michael rose through the agency with positions in Flagstaff, Arizona, Las Vegas, Nevada, and Salt Lake City, Utah, where he currently lives. Mike is currently the chief scientist in charge of science and training across the 8 western states. Mike.
I got this.
Oh, yeah.
Yep, we're good. Thanks. Can everyone hear me? Sounds loud enough, right? All right. Yeah, so I have a few slides. Hopefully folks will be able to see some of the figures. They're always small. I'll try to explain things as we go along. You probably already read the quote here. But my agenda, we'll be going through just a brief introduction of myself again. We'll be looking at some scientific evidence of climate change, just to get us all kind of in the same arena in terms of what we're talking about. We'll talk about some ramifications. Then I'll talk about the heat risk project, which I'm the primary developer for, and that got released this year to address, you know, the heat that's just becoming more and more apparent across the country. We'll be taking a little bit of time looking at some things that we can do, you know, as individuals, and then hopefully, there'll be a lot of time for questions, and we'll see how it goes. So, surprisingly, for a scientist, I have some Catholic references here. If you're not familiar with those 2 references that are listed there, one from 2015 and one from 2023, these are from Pope Francis. The Catholic Church is firmly has firm, support that climate change is real. So when Catholics, say we don't know if it's real or not or whatever, the Pope is pretty much saying it is, right? So the second book, I think, is the one I would recommend. It builds on that first one, and it's a pretty easy read in terms of going through some of the beliefs and some of the facts from a Catholic point of view. And if you search for those two on the web, there's plenty of resources that take those and parse out the information, essentially, that you can get to it even if you don't have the books. Some key quotes that you can pull out of those. Climate change is one of the principal challenges facing society and the global community. The effects of climate change are borne by the most vulnerable people, whether at home or around the world. It's no longer possible to doubt the human or anthropogenic origin of climate change. Some of the effects are already irreversible, at least for several hundred years. The increase in global temperatures of the oceans, their acidification, we'll talk a little bit about that. The decrease in continental ice sheets. The Pope says, I feel obliged to make these clarifications, which may appear obvious, because certain dismissive and scarcely reasonable opinions that he encounters even within the Catholic Church. And the final one is another quote from the book, that the change in average surface temperatures cannot be explained except as the result of the increase of greenhouse gases. That's pretty conclusive, right? And that's from the Pope. Of course, there's scientific references, which the Pope obviously relies on for those facts. Scientists have been studying this for a long, long, long time. And so every few years, there's this climate change report that comes from many countries, essentially. Authors from various countries do research. That research gets synthesized into essentially the latest understanding of what the global scientific community thinks. This isn't something that just comes from the United States, from the left, liberal community or things like that. It's from 67 countries. Authors have contributed, and the key findings in that summary are approved by the 195 country members that are included in that. 195 countries, word by word, approve what is in that summary. So China, the United States, Finland, Australia, they all agree. Those words they all have to say yes to. If they don't, they keep working on what they're willing to. So this is a watered down version, right? If 195 countries have to approve the words, these summaries are probably pretty watered down to make it so that all those countries are willing to sign in on it, right? So it's probably not quite as tough of language as we even would want it to say. Then in the United States, the Global Change Research Act of 1990, there's a mandate that we within the United States do something similar. And we look at all the research that's happening within the United States and the changes that are occurring at the regional level, so like the Midwest. Those findings go into a report that's delivered every 4 years. Those are available. We're right now on the 5th climate change and the 5th national climate assessments. The 6th ones are being worked on, and that's just something that's just going to keep happening as we go through time. The nice thing about these reports is they include confidence measures. I think lots of people feel scientists are just saying it's 100% this or 100% that. And if you read the words, it's highly likely. It's medium confidence. It's low confidence. They go and say those things. Again, the scientists are really good about making sure it really says what it's supposed to say. Lots of times the media and people are the ones that go one way or the other with 100% or 0%. So that's why I think those resources are really useful, is they're very honest, but probably conservative reports in a way. All right, so let's look at some scientific evidence just of climate change itself. Some of this is going to be really, you already know this. For some people, maybe you'll glean a few facts out of it. But how do we know that recent climate change is primarily caused by human beings? There's a lot of lines of evidence that scientists can look at. It isn't just looking at thermometers at airports. There's tree rings. They can take ice samples in the Antarctic that go back thousands and tens of thousands and hundreds of thousands of years and sample the oxygen bubbles that are in there and look at how the structure of those atoms and those compositions of gases that are in the oxygen, and they can determine kind of what the proxy temperatures were at that time. They can look at the fossil record, tree rings, right? So there's all these other sources that they can put together to create a string of temperature readings, essentially. And all of them really say that something's happening really weird, really differently right now than what has happened in the past. The change is really, really fast. So the greenhouse effect, this is something everyone probably has heard about, right? And usually it's in a negative connotation. The reality is we should be really happy that there is a greenhouse effect, because that's the real reason that we live on this planet, that we're able to live on this planet. There's gases in the atmosphere that allow the sunlight, which is the primary source of heat for the Earth. When that energy comes into the atmosphere, it warms the planet, right? Anything that has a temperature essentially radiates or emits a temperature as well. It emits radiation, essentially. So after the sun has been in a brick house, after the sun sets, the brick house is still warm, right? The Earth does the same thing. So it sends out its energy. That energy encounters certain gases that are in the atmosphere, and those gases reflect that energy back towards the Earth. Otherwise, it would just all go to space, and we would just cool off, right? That is the greenhouse effect, kind of like a greenhouse with the glass. The sun comes in, heats up the greenhouse, right? It's not exactly the same thing, but it's for simplistic purposes, that's how it works. So some of the sun's radiation hits the atmosphere and bounces off. Most of it comes into the atmosphere. Some of that energy then leaves the planet and is trapped within that greenhouse gas layer and is kept on the planet, essentially, to keep it warm. The reason that's important is because, science tells us that without the atmosphere, without these greenhouse gases, the planet would average about 0 degrees Fahrenheit. There would be mostly ice on the planet. We wouldn't be in this church right now. So the fact that we have these gases in the atmosphere allows the planet to instead have an average temperature of 59 degrees Fahrenheit, which allows all 3 forms of water to exist, which is really important for life. So the greenhouse effect itself is good. We're here because of it. But when we have those 5 different gases that are listed there, water vapor, carbon dioxide, methane, nitrous oxide, and then some fluorinated gases, when those get out of balance, then the greenhouse effect can be augmented. It's like adding another layer of glass to the greenhouse, so to speak, or making it clearer or something, so that the heat just continuously builds up. That's what scientists are saying is happening. So they measure greenhouse gases really, really well. And as I said, you can go back into ice cores that go back hundreds of thousands of years, and you can also measure how much carbon dioxide is in those air bubbles, how much methane's in those air bubbles. There was no fluorinated gas because that's a man-made gas. And they can measure that and compare it to where we are right now. We also have an observatory in Hawaii, which is in the middle of the Pacific Ocean, right? That's as clean of the air as you can get. It isn't near a big factory, or it isn't, by Chicago or New York, where you're going to get a lot of contamination from the city itself. It's in pristine air, essentially. And since the late 50s, they've been measuring the level of carbon dioxide. And you can see that little stair step going up from 1958 all the way up until the present, and that's the Earth breathing. Since the northern hemisphere has a lot of land mass, when the trees put leaves out and everything, carbon dioxide is brought in to those leaves and everything in order for them to do their thing. In the fall, that breaks down and everything, and so carbon dioxide levels across the whole planet in the northern hemisphere, where this is, but you see it in the southern hemisphere as well, goes up and down seasonally. 2023, the average parts per million. So these are carbon dioxide. There's 421 of them if you counted a million molecules in an atmospheric, if you took a cylinder of air and counted all of the carbon dioxide molecules in it, there'd be 421 for a million of them. A very small number. But it's a very powerful gas because before the current age, the concentration for the last 800,000 years never got above 300. And that's enough to keep us at 59 degrees Fahrenheit. Right? Now, we had ice ages and all that, and that's, of course, the temperatures went up and down because the carbon dioxide changed, the ice sheets advanced, and everything like that. Scientists can model all of that. This, on the other hand, the fact that it's up here is something different. And it's only going up. Right? So water vapor actually is the strongest greenhouse gas that's out there. And water vapor is about 5% of the atmospheric composition. It's a much bigger number. But water is pretty much what water we have on the planet is the water we have on the planet. There's no other place, for it to come and go. So that really isn't contributing to climate change because it's not like the water's increasing on a planet. The atmosphere is holding more water vapor. We'll get to that a little bit later because of the warmer temperatures. But water vapor actually is responding to climate change. It isn't driving climate change. Carbon dioxide, though, is driving climate change. In the past, carbon dioxide went up and down because of what was going on the planet. It was a lag kind of a situation. When the temperatures dropped, carbon dioxide dropped because there were less trees when ice sheets expanded. Now we're doing it the opposite. We're increasing carbon dioxide, and the temperature is catching up. So if we were to just stop emitting carbon dioxide for a decade, the temperatures would still go up on average because the planet is lagged with response to the carbon dioxide now. It isn't driving it. So based on that record, we can really, again, the report says it's very likely, not 100%, but it's very likely that this reading is the highest that we've experienced in the last 800,000 years. So this is really small on there, but if you look on the figure on the left, this is 1990 to 2019, and you can see that the rates of carbon dioxide that are from fossil fuels is this blue area here. The green area is the carbon dioxide that's from land use, so that's agriculture, forestry, burning of the Amazon forest, that kind of stuff. The yellow area here is nitrous oxide. Nitrous oxide comes from a lot of agricultural practices. In fact, fertilizer use is the primary source of nitrous oxide. You can see how big of a contributor it is. And then fluorinated gases, those are the new kids on the block. Those are things that are from like refrigeration, consumer products, those kind of things. So we're making those. Those aren't really natural molecules that are normally out there. They're all going up. If you can kind of see the charts here, each one is for each one of these. They're all going up still. So most people always ask me, well, it's the sun. It's the sun, right? That has to be doing it. If you look at the right-hand figure here, we've been measuring the sun really quite well for quite a while. And we know that the sun has solar cycles, right? Every 11 years, it goes up and down. We're in the midst of a pretty good solar activity right now, right? We're in a solar maximum, essentially, and then the solar activity is going to go down. The fine little ups and downs that you see at the bottom, encased by this yellow line, those are the solar cycles going back to 1880. And if you take the average of those and kind of smooth out those, you see that, yeah, solar activity did go up, and now it's kind of on its way down. Solar cycles, the last 3 cycles, have been lower than they used to be back in the 60s and the 50s. temperatures, if the sun was driving this, temperature should be going down. The red line is the temperature line. So the sun is giving us all of the energy. It's the greenhouse gases that are holding in more of that energy than it used to be holding. So the sun's contributing, obviously, but it's not contributing much differently than it's been over time. It's a very small difference that the sun does from each cycle to each cycle. That can't be explained by that. So we know the natural greenhouse effect is it's a natural thing. We want it. We want to live on the planet, so we want it to be there, right? But it's kind of a little bit out of control. We know there's a relationship between greenhouse gases and the Earth's average temperatures. They can look back in time. Again, with these proto, kind of biological and ice core samples and see that there's a nice correlation with it. And in fact, if you do put carbon dioxide since 1850, which is the red line, and then you put the average temperature of the globe on it, again with a different legend, it's pretty close, right? Obviously there's differences or ups and downs, there's other things going on and everything like that. It's important to remember this is happening in the background of a lot of other stuff. Volcanoes go off, right? We're polluting the atmosphere. Now we're cleaning it up. I mean, there's a lot of things in that noise essentially for that. But when you remove the noise and you look at the general trends, it's really hard to say this isn't something really important to this question. If you take a look at a longer sample, I get this question a lot too. Well, it was hotter a long time ago. When the dinosaurs were on the planet, ferns were all over the place, Antarctica had trees on it, right? Absolutely. And when we model those climates and we put all the continents near the equator and there's no ice cap, of course the Earth is warmer. When we put in the fact that CO2 was at 1,000 or 2,000 parts per billion, obviously the planet was warmer then. But there were other things going on to make the planet warmer at those points, especially volcanism. There were a lot of volcanoes going off when the dinosaurs roamed the planet. We don't have that now. We would not be missing volcanoes, right? Not on the scale that we're talking about. So sea levels were really high, rainforests were everywhere, there's no ice sheets. Yeah, the temperature at that point was 12 degrees above where we're at right now. We can explain that. After that, though, the continents moved, the volcanism diminished and everything like that, and the temperatures just kept going down and down and down until we're into this period here of that last 800,000 years that we've been talking about here. Remember, this is when early humans came into existence about here. We right now have more CO2 than the human species, essentially, has experienced. That all happened before that. So this is unprecedented territory for us. And obviously there's little ice ages, there's other things you can go back to the record and look at local locations where it was cooler or warmer, that a lot of that can be explained by ocean currents and again, different things going on at the time. But if anything, we should be entering another ice age. That's what science tells us right now. The temperatures should be cooling on this planet because we are in this series of ice ages. We're not. So why do we have all this carbon dioxide? Why is methane so high and everything like that? When you combust stored carbon dioxide, which is essentially what coal and petroleum is, when we had all those rainforests, when we had all that tropical, plants everywhere, the trees that were taller than this church, essentially, when they all were deposited into mud and they turned into coal and petroleum and all that, we sequestered away gigatons of carbon dioxide. We put it away. It was never going to come back out into our atmosphere. All that stuff from the volcanism ages, it's in the ground, never to be seen again until we came on the picture. And literally, since 1850, we have released hundreds of thousands of years worth of carbon dioxide. in 150 years. That's why it's getting out of control. We're going back to that climate we had before where the carbon dioxide was so much higher. We're bringing it out of the ground and we're releasing it. And we know that that happens because this is what chemistry tells us happens. Combustion has to create carbon dioxide and water. That is how it works. If you look at where the majority of that is happening from, again, heat, production, electricity, that usually gets a lot of the bad press. Industry, 21%. Transportation sector is 14%. Buildings, concrete is a big producer of greenhouse gases, 6%. And then agriculture, forestry, and other land use is another quarter of the emissions. This chart here is pretty neat here. If you go back to 1776, the founding of our country, and you look at the consumption, essentially, of energy and the sources of that, up until about 1850, it was just wood. And then about 1850, we discovered coal burns really good. And we started burning it. And that's the black line right there. And I'm not to the hope section yet, but look at what's going on with the coal chart. The black curve right down here, you see the coal curve is going down. Because coal is one of the dirtiest forms of that carbon, us essentially regulating and moving to other forms of combustion have allowed that particular trace to actually start going down. Natural gas is actually quite a bit cleaner than coal. It still is emitting a lot of carbon dioxide and water. Don't let the industry fool you. But it is cleaner than coal. So if you have to pick a poison, natural gas is the poison to choose. Petroleum has kind of leveled off. Nuclear has leveled off as well. Clean energy, but bad residual, right? You know, solar and wind are starting to pick up here just on the right-hand side of that chart or whatever. So probably pretty small here. You can look at the slides, you know, when I'm gone. I'm sure they'll be available. But as I mentioned, you know, I can't go over the fact that ag is a sizable contributor to the emissions, and there are plenty of sources, you know, on the farm that can contribute to these greenhouse gases. So when you add it up, the science is really clear. Do we know everything? No. We know a lot, though. We know the smoking gun. There is nothing else that really can explain the magnitude of what we're seeing. And it really makes sense if you think about how chemistry works with combustion and the fact that we know everything that's in the ground that we're burning is fossilized carbon dioxide. And then you look at the past, when the carbon dioxide was higher, what was going on, it is really, really hard to say that is not what's going on, all right? So Pope Francis, you know, again said it's no longer possible to doubt that it is a human origin. And it can't be explained except as a result of greenhouse gases. So as Catholics, our Pope, you know, has written 2 books, you know, on this topic. So it's really hard for us, I think, to say it has to be other things or it's natural or it's just weird weather or that kind of stuff. The science is very, very clear. All right, so let's talk about some ramifications of climate change. I'm going to check my time just to make sure we're not going way, way over. So I think everyone's aware higher average temperatures. In the past, you know, it used to be called greenhouse warming, right? The scientists have gotten away from that, and again, some folks say, oh, it's just political, or it's just they're just trying to change what it is or whatever. But we had to do that because people were pointing out the few locations on the planet where the temperatures were actually going down. And again, this isn't a universal thing. Like the southeast United States, the temperatures have been going down there, except in the last decade, they now have really started to go up. But they were going down because they were seeing a lot more rain in the southeast, and the clouds were holding the temperatures down on average. Explainable. Antarctica, a lot colder temperatures there. Models say it should snow a lot more in Antarctica because of the extra water vapor and the warmth that's in the atmosphere. That's what was going on. Now that signal has changed. It's warming up in the Antarctic quite a lot. So it's climate change because it affects other things. Droughts are longer lasting now because if the temperatures are warmer and you don't get precipitation, it's going to evaporate that much faster, right? But we also get heavier precipitation. That's kind of the weird thing about climate change is that it augments extremes. And for precipitation, it augments both sides of it because either you're increasing the evapotranspiration from the plants or the evaporation as a whole, or the atmosphere holds more moisture in it, just like a sponge. When the temperatures are warmer, you can hold more water. When we get a downpour in Wisconsin, it can be pretty heavy, but when do we get the heavy downpours? When the dew points are really high, right? There's a lot of moisture in the air. If you go in the tropics, it rains heavy a lot all the time. It doesn't do that in Alaska. That's because of temperature. There's a temperature and a moisture relationship. So as we warm the whole globe's temperature, the entire globe, that atmosphere can hold a little bit more moisture, and that's why now hurricanes are producing that, again, very likely, not 100%, but scientists feel it's very likely that there is a trend in hurricanes in terms of rainfall rates and in rapid intensification as they encounter the warm waters near the coast. We don't know if there's more tropical systems. This year, I think, is a really good example of that. It was supposed to be Armageddon, right? And we're just on the, we're getting ready for the L storm, essentially. It's been taking a while. There's other factors that have inhibited the hurricanes this year. It isn't just temperatures and moisture that have been driving hurricanes. There's other factors. So again, the science isn't clear yet if severe weather, tornadoes, that kind of stuff, there's no clear signal yet that climate change has a hand in it, but I think based on the fact that we had tornadoes in February in Wisconsin this year, didn't we? That never happened before. It's one data point, but it does go along with what we would expect. The extremes become more magnified. Wildfires, you had smoke here, right? I don't think a lot of you remember years where we had a ton of forest fire smoke here, right? It's becoming more common. Out in the West, it's every year. It wasn't like that. And so there's human practices, obviously, about how we maintain fires, how we didn't put them out in the 50s, 60s, 70s, 80s. Smokey the Bear was very bad, for that advice. So we're reaping the ramifications of that, but it's on the background of the fact that we have a hotter and drier West, that now the fires are just, they just go out of control. So the last year and a half was kind of a taste of what's to come. A complicated chart. January through December on the bottom here, this is the departure from a pre-industrial reference period. So if we took the average temperature of the globe from 1850 to 1900, so back when we were just burning a little bit of coal, we kind of had a more stable climate. 0, that would be the average temperature that was there. All these lines represent all the years since 1940. They're all mostly above 0, meaning that they're all warmer than what had happened pre-industrial. These top 2 lines are essentially 2023 is the orange and 2024 is the red. They are above all the lines by a lot. As a scientist, you look at this kind of a departure and you're like, holy moly. Because look at how these always have been on top of each other. They just slowly go up. This is huge for scientists. Oops. This 1.5 degrees, lots of you probably have heard that that's this mystical threshold that we aren't supposed to pass, based on some of the agreements that have been made by a lot of the countries. We want to keep the climate at 1.5 degrees or below, because worse bad things can happen above 1.5 degrees. They become much more likely. 2024 and 2023 are about as close as we have ever come to that, and in fact, they're very close to 1.5 degrees. So this year and last year are representative of what, on average, we may see by 2040, based on the current rate of increase. Pretty scary stuff. So, some questions. Winter's still going to happen. The sun still turns off at the Arctic in the winter because of the axis of the Earth, right? When it's dark for 6 months, it gets awful cold up there. That cold air has to go somewhere. South is the only direction it has. So winters are always going to be there. The problem in a climate-enhanced temperature kind of world that we live in is that there's theories that the jet stream, which is pretty much what kind of controls where the cold air and warm air is, the jet stream kind of sits, it has to based on physics, it sits between cold and warm air. So always when a jet stream south of Wisconsin in the winter, you're on the cold side of the jet stream. When you get these wobbles in the jet stream, that's when the polar vortex comes down, right? That scary thing that you heard about 10 years ago and now it's in the media all the time, right? That's always been there. Those are still going to happen, and in fact, some of the literature suggests that because of the fact that we're pushing warmer air more towards the poles, and yet the poles are always going to be cold, you're enhancing that difference, which causes low pressures to spin up on it more readily, which causes waviness in the jet stream pattern, which then causes that cold air to dump into the Midwest. So what climate change may look like in the Midwest is more often than not, you'll have early springs and milder winters. But don't look too hard, because lurking somewhere in the Arctic is a brutal cold wave that'll come down and kill all of the early vegetation, or still give you 30 below temperatures, but maybe it'll only happen for a week or two. More variability, essentially. But winter's not going to go away, but when you average all those days out, it's going to be warmer. But a lot of you remember that 2-week period in January where it was minus 37 degrees, right? Or last winter where it wasn't cold at all, where it was winter, right? So I think, that these late freezes are really going to be a big impact for agriculture. And trees especially, they can't move. We can change crops, we can change how we do things, we can geneticize, new crops that are more resistant and things like that. But when the peach tree blossoms are out or the cherry blossoms are out and the freeze comes, they're done, right? That's the impact. And for farmers, year to year, it's the variability that just kills you as a farmer. So this is not good, because this says there's going to be more variability in winter. And in fact, if you look at Stephen's point, summer hasn't changed much at all. The trend is really only about 0.1 degrees every 10 years, because you get a lot of clouds and thunderstorms here, and so that really is mitigating a lot of the warming that you would see in the summer. And you are seeing a much enhanced rainfall rate here, I will tell you that, over the last 2 decades. Rainfall rates are going up here. Winter, though, you do have a pretty significant trend, more than half a degree every 10 years. So every 20 years, the average winter temperature has gone up a degree. And that goes back to 1944 that we're looking at here. Most of the climate change signal really starts about 1975 or 1976 is where it really starts to increase. So we're going back further than that, which is probably kind of muting a little bit of the enhanced signal. So that's another thing people look at. Oh, is it getting any warmer here in Wisconsin in the summer? Well, you're right. But there's another part of that equation. So snow, obviously, I just glossed over that, but snow obviously is going to be tougher if you have a warmer winter. You'll have a few more rain events, you'll have tornadoes in February, but not all the time, In fact, you may not have another episode like that for another 15 years, but it's becoming more and more likely. Droughts and floods, like I talked about already, both droughts and floods are more likely with increased temperatures. And again, it's based on this idea that with warmer air, if you think about, the air at 50 degrees is a sponge that's this big. If it's at 70 degrees, the sponge is bigger. It can hold more water, and then I can squeeze it out more. That's how the atmosphere works. That's just simple atmospheric science 101. You also get more evaporation because warmer temperatures just drive evaporation from soils. So that's how droughts get more augmented. So it's a weird thing. Normal becomes less normal because the extremes become more likely. Really a weird concept, right? So we're all familiar with the polar bear on the ice cap, kind of a thing. That's kind of the emblematic picture of the change in the environment. But sea ice really is melting when you look around the globe. The trend is pretty clear that in most places, the sea ice is melting. From year to year, you get variability in the Arctic especially. You'll see that one year it'll be like, oh, now it's the 13th least amount of ice, in the historical record. Well, that's nice, except the 18 lowest years have all occurred in the last 18 years. So all we're doing is just shuffling around within that envelope, essentially. And the other thing with sea ice, is that in order to be really reflective and protective of the environment, essentially, the ice is older ice. 5 years or more, it's thick. Once you melt the thick ice, then all that you create every winter is thin ice that melts the next year. So once you lose the thick ice, it is really hard to get it back. That's what's happened over the last 18 years or so. That amount of ice is going down. Every year we might get a little bit more thin ice, a little bit less thin ice, a little bit more thin ice, but unless you have like 4 or 5 or 6 cold years up there to get the thick ice to go back, it's gone. And that's why they're talking about shipping routes being able to go up north of Canada all the way around and everything, is because the thin ice they can break with an icebreaker. The thick ice they could not. Sea level rise, the ice that's in the ocean, that doesn't contribute to sea level rise at all. If you think about an ice cube that's in your glass of water, when it melts, the level of your water doesn't go up at all. It's already displaced the amount of water it's going to contribute when it melts. What's contributing to sea level rise is all the ice that's on land. What's the biggest landmass that has ice on it in the northern hemisphere? It's Greenland. That's why we're worried about Greenland. That's why we measure Greenland. That's where it matters. Greenland is losing copious amounts of water every year. And the bad thing about that is it's not only that sea level rises, it's that amount of fresh water going into the ocean, there's ocean currents that essentially go all down and up through the oceans, transferring heat from the bottom up to the top and transferring heat from the top down to the bottom. When you put a lot of fresh water around Greenland, that part of the current starts to weaken. The reason Europe is as warm as it is because the Gulf of Mexico water goes towards England. If that circulation slows down, Europe cools down a lot. Guess what the Little Ice Age, what happened? That current is speculated that slowed down, causing it to get colder in Europe for several decades. Sea level rise isn't going up everywhere either. The thing that we have to remember is that we had a lot of glaciers on top of Wisconsin during the last ice age, right? And that wasn't that long ago, if you think about it. A couple tens of hundreds of years, right? So the continent is still rebounding from that. It is still going up because of that ice that pressed North America, where the Great Lakes are down, is now going up. So is the eastern seaboard. So some places, sea level rise is not happening fast enough with the rate that the continent is going up. And so you can find places where sea level rise isn't going up. That's a red herring. It's going up everywhere. You can't hold water back from this particular harbor. It's the fact that the harbor is going up because of ice melt and everything, and the continent rebounding, essentially. That's causing that to be different. Or currents or other things, but it's explainable. But people always point towards these, oh yeah, but this place isn't. You got to explain the whole enchilada, right? Yeah. Flooding, warmer oceans, marine heat waves. We've heard about these marine heat waves. The oceans last year were the warmest they've ever been recorded. We are losing coral reefs in places that have had them documented for as long as people have been in little boats. We're losing them because the water's too warm for those creatures that live on those. And once they're gone, they're gone. It takes lots of time to restore a coral reef. So a lot of ecosystem stressors that are here. You've probably been able to already read that white box there, but I think the important thing is right now the oceans have been saving our butts. 93% of the heat that should be in the atmosphere has been absorbed by the ocean. The ocean is very big. So it's like a battery. It slowly is taking on this heat. But what happens is even if we get a technological solution to carbon dioxide emission and greenhouse gas emissions and somehow, again, we turn it off and we don't emit any more and it goes to zero, those oceans are lagging. They're still warming up. They're going to still be emitting heat for a while. And those currents are still going to be bringing that heat from the bottom of the ocean up to the top and doing all that. And so that's part of this. There's this lag with the oceans, which is great. It's saving our bacon right now. Scientists don't know how long this will continue. It may not be just a forever thing. What if the oceans all of a sudden go, oh, I'm only going to store about 50% now? We don't know. Oh, I did have a thing that didn't come across well. So agriculture is that word. So we already talked a little bit about this, but yeah, less predictable growing seasons, soil health issues, water quality, that's a pretty big thing, right? That's in the news quite a lot. So even if you're not believing climate change or the temperatures or this or that, I think we all can agree that water quality is pretty important, right? I think that's something we could rally around. We see in the news a lot about food shortages and insecurities driving populations to feel like they need to go somewhere else where there is food and more security. Probably folks here that have farms have noticed crop yield changes with this. Heat stress in animals, right? So CO2 does have a positive effect on photosynthesis and water retention in certain crops. But it also reduces the nutritional value of food crops because when they grow faster, they spend more of their energy essentially in growing and less in food content essentially. So that also is a kind of you wouldn't really think about that, right? So really it's a negative thing overall when you put that into context. This one I think most people are pretty well aware of. I think the biggest thing here is species that can't move or migrate. So in North America, when they study plants and that, they would need to move essentially vertically 36 feet every 10 years or northward 10 and a half miles or so every decade in order to keep up with how the plant growth zones are changing. I know in Salt Lake City, we actually changed plant hardiness zones in the last release. We went into the next warm one. That shouldn't happen in a stable climate. Plants can't move that quick. So what we see out west is places that are on the margin where they had a lot of juniper pine forests that burn with wildfires. What comes back is grass, because the trees aren't able to get a foothold anymore because the climate's changed enough that they no longer can germinate and grow there. The adult trees are able to weather that a lot more, but new growth is not. And so we're seeing grass take over the juniper pine forest areas when they burn, unless they're higher up or in places that get more water and that. So we're already seeing some of that effect. Trees can't move. Humans, again, the smoke you guys experienced last year from Canada was pretty miserable, right? I think we'll all remember that. But in the news, mosquitoes with disease vectors in New England now, the ticks, Some of that news is really, really scary, right? I mean, it's things that haven't happened before. Malaria is moving northward. I mean, again, that's all a signal of climate change, that these diseases also are going to be moving because the vectors, those insects or those bugs or those animals that transport those, are able to move into new environments. When things are bad with stability in food, populations displace. They go to other places, and we're seeing that happen in Africa, right? So as this happens, these forced displacements just become more likely. So these economic impacts are pretty big. We're all familiar with Lyme disease. I didn't know that in Canada, Lyme disease really wasn't a thing until recently. Now the ticks can live there. Before, they couldn't make it through winter. All right, so enough doom and gloom, right? So let me talk a little bit about the Heat Risk Project, which is the project that I was the program manager for and the developer of. So this is a new way that we in the National Weather Service, in partnership with the Centers for Disease Control, developed a new index essentially for identifying heat that is more locally based than the other systems that are out there. It went national this year. I've been developing it in the western United States for 10 years, and it expanded, and we've been using it in the western 8 states where I've been involved with for the last 8 years, and we've been using it for issuing our excessive heat products, essentially, in our heat advisories during that time period. And those states have become quite tied to it, and in fact, they close schools, they close hiking paths, they do things based on this index, and we're hoping that now that it's expanded nationally that we'll see things happen based on this index in other parts of the United States. It's a simple color number system. I wanted something that you didn't have to know, is 105 heat index bad, or is it 95 where I'm at, or is it 97 or whatever? This just says it's orange today. And these are the things you should do for that. It's a level 3. Really easy to message. It puts it into the right context for your particular location. You don't need to know how many people have died or succumbed to heat and how that correlates with the temperatures and which temperature is dangerous and how many hours of exposure should you have for that. It's all in here. So it takes into effect how unusually the heat is for the time of the year. So if it's an early season heat event, the epidemiological studies show that the more humans are succumb to early season heat because they've been through all winter without being tested, essentially. So that first heat wave is really dangerous. And we overthink that we are more resilient than we are, especially as we get older, or medications make us more sensitive, or various things like that. Or we're a normal human being that's just sitting in a stadium watching, an athletic game, drinking some adult beverages, and we also are vulnerable when we do that because we aren't hydrating, we're not cooling ourselves. And the thing that separates us out from heat index and wet bulb globe temperature and those other indices that you may be familiar with is that we actually worked with the CDC to identify and use the data that they have based on actual heat health data to identify the temperatures that are critical for Stevens Point, or for Madison, or for Chicago, and they're different. But yet, if you look at what the Weather Service currently puts out, it's just a heat index of 95 is dangerous, period, no matter where you're at in Wisconsin. This recognizes that along the lake, your exposure is different, your resilience to heat is different because the lake modifies the temperatures, right? It takes all that into consideration. We also approximate the role of moisture in there, even though it's a temperature-based measure. As we talked about before, the warmer the temperatures are, the more moisture that's in the air, and one of the ways that we correlate it with is the low temperatures. In the summer, when it's a really humid day, do you end up having low temperatures in the 40s overnight? No, they're usually in the 70s, right? Maybe near 80, right? So that's how we can do this. Low temperatures are a proxy for moisture. And if you don't have air conditioning, does it matter if it's really, really humid and the low only gets to 80? It's still only getting down to 80, right? So that's all in there. The numbers and the colors are all based, again, on the risk that you could suffer from heat-related impacts. Levels 1 and 2, the yellow and orange, are primarily for those heat-sensitive populations. So a lot of folks there's medications that make them more heat-sensitive, the elderly, the young. As I tell people all the time, when you're sitting in a football stadium in September and the sun is beating down on you for 2 hours, or you're waiting outdoor to get into the fair and you're drinking beer, you, my friends, have entered the at-risk group because you're not taking the precautions that you need to take. And you are at risk. And I can't tell you how many days when heat risk is orange, people are carted away at the county fair that was going on that weekend, or at the football game where people were sitting in the sunny side of the stadium and not taking, precautions and everything like that. We don't think about that normally, I don't think. We go hiking on a day when it's 90 degrees because it's like, well, I had that planned. Maybe we shouldn't do that on an orange day. Red and magenta are the highest levels, and those are where more of the general population even could be impacted, especially if you don't have air conditioning. That is the biggest contributor to it. But if you're outdoors, you obviously don't have air conditioning. So then you are much more at risk. But again, the numbers in that are pretty easy to understand. And this is this year's data for, what I do is I compress it all into like a time strip, essentially. And so Madison's at the top, Chicago's in the middle, Stevens Point's the one in the third one down, and then Phoenix, just as comparison, is at the bottom. And again, January through December, I pulled these in the middle of September, so they end there. You guys didn't really have any appreciable heat after September anyways. But you can tell how, between June and July, there was your first heat event here in Stevens Point was just a level 2. It was just an orange one, but it probably had a bigger impact on the population because, again, it was the first heat event. But in Chicago, their minimum temperatures, that was a pretty significant heat wave for Chicago. The minimum temperatures did not go down very much. The index said it was a magenta one because, again, it was the first season's heat. It had very warm minimum temperatures, so there's no recovery at night. Buildings could warm up if they didn't have air conditioning, or if you're a transient population outside, you weren't able to cool off. And so you can see that it highlighted that to be more. And it kind of makes sense. Further south, Chicago's heat waves this summer have been a little bit warmer. Madison, mostly reds, and then Stevens Point here have been mostly the orange ones. It hasn't been really a bad summer here, right? We had a couple warmish days, but nothing really off the records. Phoenix, on the other hand, I don't know if you saw, but they had the most number of 100-degree days consecutively that they've ever experienced by like 20 more. And you can see that it's essentially saying that almost every day in the summer were dangerous to that vulnerable population, essentially. And there were periods in there that were really, really dangerous. And I have no doubt that they will probably have more heat deaths in Maricopa County, where Phoenix is, than they probably have seen before. Just as an indicator, last year they had over 550 deaths contributable to heat just in Maricopa County, where Phoenix is. But that means that people had heart attacks, they had asthma attacks, other things get aggravated with heat. It's not just people just, falling over in the street and dying. It augments other health impacts as well. So this is just a loop from 2023, and all those points are essentially observation points that we have data for. And essentially, it's really neat to kind of see how heat moves across the country and the different levels that we had. We're in July here. Last summer, a lot of the heat was in the south, as you remember. Texas and Louisiana, really, it was bad. But we had a late August event that happened across Wisconsin, and then early in September, there was another one. That was actually the two worst periods last summer, were those very late in the season episodes as they went through. But it is pretty cool to see how the heat just kind of moves across the country and moves across, and most of the red and magenta are where, we're further south where the temperatures are much warmer, obviously. But yeah, pretty interesting. You can find it at this website here. It's a website that I designed with a few other people. And it has the whole 7-day forecast on there. You can zoom in. If you click on it, you get the temperature forecast. And then at the top is the readout of the different indices for that particular 7-day period of time. There's tons of information about our collaboration, what goes into it. There's verification. It's a pretty robust system. Yeah, I'm pretty proud of it, actually. It's a pretty cool thing. Yeah, I have pictures of President Biden briefing on this, so that was pretty cool. So hopefully you'll be hearing more of it. I know you've seen it on TV because I have some screen captures from some of the local channels that have also been highlighting it earlier in the year when it was released around Earth Day, and so hopefully you'll be seeing it more in the upcoming summer. All right, let's get to some hope. All right, so at this point, I'm going to take off my official government hat, and I'm just going to be talking to you as a regular American citizen. The Weather Service and NOAA, we generally don't get too much into the solution space. It's very political. I'm not going to represent my agency when it comes to those kind of things, but I am an American citizen. I do have an opinion. I think it's a pretty valid opinion, so I'll share some of those ideas with you, but just know it's coming from me as just a regular, one of you, essentially. So the biggest challenge with this is it's a global problem. So the solutions really are going to have to be global. This is a big problem. We're taking hundreds of thousands of years of sequestered greenhouse gases that have been in the earth, and we are just consuming them in the order of decades. It's a huge problem, and it's not one we can just change really easy. So we really need large solutions to do this. So personal solutions are needed, but it has to be in conjunction with very big, funded, government-size solutions. So we have to mainstream effective and realistic things that we can do, knowing that it is such a big, big problem. Because we have to think about not what we can fix today, but what our children and their children are going to get from what actions we take now. We have to be in it for the long game, and I think that's what has to change in the country is we have to stop thinking a little bit less about what is going to help me and think more about what's going to help the next generation, because that's the scale of this problem. So lots of people, I have a cousin who's just like, we should just stop fossil fuel use. We just need to stop it and just go to solar and wind. That isn't realistic. It just isn't. So many things in this church are made out of petroleum. Almost every plastic you use is made out of petroleum. Household goods that you use every day are made from petroleum. That little figure that you can't see, everything that's in there comes from petroleum. Toilet seats, toothbrushes, detergents, pens, dolls, building blocks, kitchen surfaces, utensils, cars. We can't just stop, right? The top 5 petroleum-consuming countries, we're number 1. It's probably not a good thing. We are the biggest consumer. 20% of the world's petroleum is consumed by the United States. China's 15.7, they're increasing quite a lot, but we're still ahead of them. I hear lots of times, China is bigger than us. No, we're still more than them. India is the third with 4.8. They have a large population that is emerging into the middle class right now. We can't tell them not to do all the things that we had the benefit of having, cars, homes, right? Recycling needs help. I think in the news you've seen there's some emerging stories coming out about how the petroleum companies have been behind some of the recycling slogans about how powerful it is. If you recycle plastic, you're making a big difference in everything. Unfortunately, only 5% of plastics in the United States are actually recycled. The industry claims that we recycle 6 billion pounds of it, and that sounds like a lot, right? we consume 116 billion pounds a year. That is a very small number. So they want us to believe waste management is working because then they can keep producing and using it, right? But we've all seen the pictures of just the piles of plastic that are in bales, that are in the ocean, that are in warehouses, that are, going. And frankly, the technology for recycling plastic is just not there yet. It is not economically feasible. And when you live in a country where profit is what drives things, recycling doesn't work at this point for plastic. So we really have to solve the problem of reducing the production of plastic so we don't have to worry about recycling it as much. Paper and glass are a bit better. About 32% are recycled in the country. Only about 15% of textiles are recycled. Clothing, I don't think a lot of people think about recycling clothing. The thrift stores, we throw our clothes away. They can be used again. Only 15%. Food waste is the most significant amount of waste that we actually do. 30% of food goes unsold or uneaten in this country. And a lot of it's because we don't want a tomato that looks weird, or a bagel that has a burn hole in it, or the food sat out because we made too much on the buffet or something like that, and we can't give it to the poor because we're afraid that they're going to get sick, and so it has to go in trash or get fed to pigs or something like that. Methane is produced when food decomposes. Methane is a greenhouse gas. Food waste contributes the most of methane to the order of 50 million cars a year of the exhaust that they would produce in terms of greenhouse gases. There are no federal recycling programs. That just boggles the mind. There are no federal regulations for recycling. It's all ad hoc. Stevens Point has a program. Wisconsin has a program, right? So we need additional funding. Technology has to solve this for us. We've got to fund projects to find out how to break down plastic into its component parts so it can be made into new plastic. But what are we going to do with dirty plastic? What are we going to do with the contamination? The labels, the this, the that. I mean, all the things that are making it so it's too expensive to do. We've got to solve those problems, and it's only going to happen with technology and funding. And that has to happen through regulation. I know regulation's a four-letter word. But this isn't going to happen without people they're pulling their pants up and making decisions on, for the greater good, what we need to do. They have to make it so that recycled materials by industry are favored versus creating new stuff that you throw away. And they're not going to do it out of the goodness of their heart. So solar, wind, the movement to go to cleaner fuel forms of fossil fuel, that's all good. That's all, it's making a difference, but it's a small difference. If you look at the upper left picture, again, you see that we have been making an impact on coal. And I know for the people that, that's places where coal is their main industry and things like that, this is horrible, right? What are we going to do? We're losing our jobs and everything like that, but there's other jobs. There's solar, there's wind, there's other things that can be turned to, but that's tough. They need skills and everything. The government has to be able to support that, those skill trainings, right? Social programs are going to be important for this. We've got to train people to go from their old jobs to their new jobs. What do I want to say here? These are really small. So yeah, coal has gone down, natural gas has gone up. Again, natural gas is cleaner than coal, so that's good. Petroleum has gone down just a little bit, and wind and solar are going up. But wind and solar is this little box right here. We got a long way to go. So until there is some revolutionary technological discovery, and Mom and I have this discussion a lot, the person who may have this discovery could be an inner city child who does not have the opportunity to go to college. We don't know. That's why education is so important, and we've got to support everyone having a chance to contribute to this problem. My worry is that China is going to come up with a solution. They're not going to give it to us. Education is so important in this. We don't know where the solution is going to come from. But until then, we've got to use the cleanest fossil fuels that we can for a lot of decades to come until that magic solution comes up. And we've got to find ways to use less plastic and throwaway items. Regulation has to make it so that industry has a reason to make things less throwaway. Fairness has to be part of the solution. The United States made this problem in large part. We know the numbers. So we have to contribute a lot to the solution, right? The problem is that people in vulnerable areas are way more impacted by this. The US has been the top emitting country in the world for decades, and yet we were one of 3 countries to not join the Paris Climate Agreement, with Nicaragua and Syria. Embarrassing. Yeah. To be fair, we need to pony up, right? The richest 1% of the global population is combined for more greenhouse emissions than the poorest 50% of the country, or of the world, and own 51% of the world's wealth. So there are some technological advances that were made, that are being made, that have been made in 2024. Some of them are actually pretty interesting. Solar cells and wind farms are going to their next generation. Solar uses a lot of petroleum. There is waste that we don't know what to do with. But as we learn more, we'll learn more about it. When we first started burning coal, it was pretty bad, right? And then it got better and better. So we have to invest in those. So this next generation of solar cells are more efficient. Wind farms are less destructive on the environment. They're finding ways to take the propeller blades and actually recycle those, because up until now there hasn't been anything we can do with that. They've just been laying around and everything like that. So we're making some progress there. Direct capture of CO2 is an intriguing thing. They're finding out that they're finding a way that they can put the CO2 into concrete, which we need a lot of concrete. If you look anywhere in any city, concrete is like everywhere, right? So if we could start putting it back into the ground, like what happened when the dinosaurs were on the planet, we know that works. We just have to do it on a huge scale, right? So they're making some progress with that. Energy efficiencies, technologies, obviously that's something. Using AI to help with savings, like right now, airports are testing out AI for how long that planes should taxi. Every minute that they save from not having that plane on saves greenhouse gas emissions, and planes contribute quite a lot. So those minutes add up when you're talking about thousands of planes over thousands of days, right? Cities, making them more resilient. We're going to have to do that because we're in this for a long, long time. So building resiliency is really a big part of what's going to have to happen. I see that I'm going very, very long. So this is an interesting, close to home potential solution, which I think is pretty cool. So cows, as we know, produce methane. When they chew their cud and everything like that, there's bacteria that are in the rumen that, breaks down the grasses and everything like that into materials. One of them is methane. And that's because one of the bacteria that's in there is a really, really old form of bacteria. So what scientists have been able to start making progress on is they're like, can we change the biology of the cow's stomach so it doesn't produce methane, thus saving like 10% of the methane that is emitted on a yearly basis comes from cows. That would be a huge thing, right? So there's 1.5 billion cattle on the planet, and they all burp methane. So each one produces 220 pounds of methane a year, about half the emissions of an average car. So that means 0.75 billion cars essentially worth of methane is produced, essentially. Or greenhouse gases, at least. And I know there's pushes to decrease eating beef or whatever, but that's not going to save the planet either. So methane stays in the atmosphere for 7 to 12 years. Carbon dioxide, by the way, stays in the atmosphere for 50 to 100 years before it breaks down into something else. So there's no reason a cow has to produce methane. That's just because of how biology has evolved within the cow's rumen. So what if the scientists could just, turn that off, essentially? What they found is that seaweed oil, if you feed that to cattle, those bacteria that are in there, it releases an enzyme, essentially, that causes the ancient bacteria, the one that produces methane, that archaea, essentially, it causes the levels of those to plummet because that enzyme keeps them from being able to eat. There's another bacteria that is in the cow's stomach that doesn't produce methane, and actually, when it breaks down the grasses, it produces energy, which is good for the cow. So the trick would be, could we make that bacteria the primary one, turn off the other one, have healthier cattle, and not produce methane? That's what they're working on. That's a global solution. That should be funded. And the cool thing is they're thinking every calf gets a vaccine. Even the beef cattle get vaccines right away when they're calves, most of them anyways. So if you could give it to them in a form of a pill or a capsule or a vaccine in that calf stage, it would be in there. It changes the biome, and then from then on it would be that way. A long way to go with this. But this is the cool stuff. But imagine the headlines: study looking at cow gut bacteria, funded by the government. Right? That's how it gets spun. This is really cool stuff. All right, so this is my last slide. So what can we do? So the biggest thing we can do is we can reduce our product and food waste. We all can do that, right? We're not going to change the petroleum industry. We're not going to, make them stop using plastic. We're not going to change how cars are created or what kind of gas mileage they get. But we can reduce our use of plastic and really avoid the single-use plastics. We should be using renewable energy whenever possible. There's more and more programs out there that allow you to buy into solar and wind. I know in Salt Lake City I can buy credits, essentially, of my power coming from solar or wind, and that money then goes to fund more advances with solar and wind. That's my contribution that I'm trying to do. Turn off the lights, conserve your energy. When you're shopping for technology, it costs more, but choose the more efficient one, thinking again, not about me immediately, but about the future, right? So energy efficiency does probably cost more money, but walk or bike somewhere. How often do we get in the car and just drive down the street? LED light bulbs, we probably all have changed those already, but if you haven't, that is a really, really easy way to save a lot of money. Those fluorescents really do use a lot of energy, and the LEDs really do not. Washing clothes in cold water, replacing windows once they get old, grow something. A lot of us with COVID, I think we learned about gardening again. Hopefully that practice continues, but growing your own food rather than having the supermarket waste it is probably better. Saving water, educating yourself, I think is really, really important. So coming to these kind of things, reading both sides of the political aspects of these, and really thinking through things scientifically. Does this really make a lot of sense? There's a lot of spin out there. You gotta vote. You gotta vote with what you want. This isn't gonna change without the right people putting in regulations, funding the right projects. That cow thing isn't gonna happen unless it gets funded. And that study's not gonna get funded, I don't think, by some people that are in politics right now. Supporting research and organizations that can mobilize bigger actions. Again, you gotta think bigger, you gotta support those bigger things. We do what we can locally, but the bigger things are gonna have to be supported. Community resilience is really important, helping each other. Do one new thing a week or a month in line with, just being a better steward of the planet is all that we need to do. And imagine if we all did 1 or 2 things a month, how much different we would be a year or 2 from now. Think about the solutions close to home. It can get really disheartening to think about all this and the scale of it and how big of a problem it is. That's not going to help. So just do things locally and vote and educate yourself and fund and buy things that are energy efficient and pray. This is a big problem. So I will leave it at that. And thank you very much.
Thank you very much, Mike. It was very enlightening. It was very detailed and very comprehensive, as good science should be. I'm Bob Walensky, a member of this parish and a member of this parish's Social Justice Committee. And within social justice, we have a subcommittee called Environmental Justice. And Sue Zock, who you have heard from already, is the chair. And Arlene Meyerhofer is a member. And I'm a member. And we're looking for other members. We just lost Karen Clifford, who moved away. And we may have 1 or 2 others who are interested. Albert Einstein said that the human race is in a race between education and oblivion. I'm paraphrasing. Of course, he was referring, when he said that, to the atom bomb. But this is another atom bomb, if you will, because it has profound implications. And now we have the really, really good science. These guys can measure anything. They can measure it minutely. They can provide beautiful detail and colored graphs and all that sort of stuff. And of course, the Pope has his advisors who know this. I don't think he knows all this kind of stuff, philosopher and theologian that he is, but he has advisors who can tell him about this stuff. And so we want to thank Michael for putting the science around what is the moral message of Pope Francis. So with that, let me ask, we have some time for questions. Please feel free to ask Michael a question while we have him here. Harry, coming over to you.
My question is about air flights. And on the one hand, airplane flights contribute to the carbon problem, but on the other hand, visiting countries that are good for tourists help their economies, and probably is the only way they can do. What I've heard is some people trade carbon credits to make themselves feel better about taking annual plane trips. What are your thoughts on that? Is that adequate, or is that kind of like just making yourself feel better?
I appreciate that they're trying to do something on their level to be able to do something. They can't do anything about planes. I think it's disingenuous to ask people to never travel again. I don't think it's that much different than folks that contribute to having trees planted in the Amazon, or other things like that. We're not going to. Personally, I believe that planes are going to have to solve the problem through technology, right? I'm not going to be able to solve that. Am I going to restrict my travel? I'm going to think about it, I guess, a little bit, but probably being realistic, probably not, right? That's why I think it's such a tough problem. But if there was a way that when I took a flight, I could contribute money to solving the cow problem, absolutely I would do that, right? So I don't know where these carbon credits go. I'm sure there's politics and spin with those. Some of them probably are good. Some of them the industry's probably saying are good. They're going somewhere else, who knows? But if I knew it was going to some of those things, absolutely I would.
Please.
Do you find that, just like in health literacy, making something understandable to people, do you find that same problem with climate literacy? And I'm just thinking specifically when you were talking about our oceans absorbing 93% is because of the heat capacity of water. And I just wonder if in science classes or somewhere that we could really explain what that heat capacity is, because most people think like, well, what's the big deal if the planet just goes up 1.5 degrees centigrade? They don't understand how much energy is being stored there, and and how this is, and what that tipping point, why they always call it the tipping point, because at some point that can't happen. And how I appreciate your graphs with those heat kind of things, because I think a lot of people now are used to those kinds of dangers and stuff, but how can you communicate, I think, really even specifically to our legislatures, if you have hearings, are they open to that, or is it just, here's 5 minutes and this is, anyway, I don't know what the question actually is, but is that an issue?
I think you've heard, I feel education is very, very important. And I feel being truthful, I could have made this more positive. I could have talked so much about how recycling is great and all this other kind of stuff and not brought up agriculture's contribution, but you got to know the facts. I'm a big believer that when you are empowered with truth, then good things can happen. And I feel that, right now with the politics and the spin and everything like that, I don't think all school districts teach this.
I think that we're lucky in this parish to be able to support the students at the university and the education, because they are the ones that can make the difference for us. Mm-hmm. So if we can find more solutions to help them, mm-hmm. I think we'll come up with, they'll develop more ideas, and mm-hmm. We really are fortunate to have that and to help them.
Mm-hmm. Reply, comment?
I agree. I think students, we need more students. We don't know where the right ideas and the collusion of ideas towards the bigger picture solutions are going to come from. So I think anything that we can do for freeing up education for people, education is where this is gonna get solved that way. We're gonna find solutions to this. Humans are gonna be around. We're gonna figure this out. It's just how painful is it gonna be, to get there.
Have you seen changes in the morale in the scientific community, given some political rhetoric to not even talk about climate change, make that taboo? What are your reflections on the last 8 or 10 years in terms of?
Yeah, I don't know. We're so politically divided. If you don't recognize a problem, or it's just called wacky weather, I don't know how you get to a common space for solutions when you don't even recognize that the problem is as large of a problem as it is. And I think most Americans know something's going on, right?
Right here, please take the microphone so we can all. No, please. It's being recorded.
I'm really interested in the farming because my husband works for a pretty good sized farm, not those big corporate farms that are out there. So is there any incentives you can do that will deal with that gas problem? Because there's thousands of cows on one of these huge farms. And if that gas is causing a major problem, if they had an incentive, because they get a lot of incentives, I know they do.
That's what's ultimately going to happen, is we're going to have to fund the technology to see if this approach actually can work. Then they're going to have to test it out. They're going to have to mass produce it. They're probably going to have some regulation, because a lot of people are going to be like, I'm not going to do that to my cows. It's going to cost
They-
money to do
They
that.
take probiotics all the time.
Right, right. That's the goal, is that it would just go into that mix or whatever. But a lot of R&D has to happen, research and development has to happen before this idea. We don't even know, they don't even know if it's going to work. This is just emerging tech kind of a thing. But those are the solutions that are really going to help. But then, yeah, do we subsidize milk? Or do we subsidize this? I mean, these are the tough questions that we have to look at. Is there's only a finite amount of money and everything. So how do we get to these solutions? It can't be looking at the past stuff, but fertilizers are a big contribution to that. Manure is a big contribution to that. There's other things, there's a lot of things on a farm that, local and corporate farms are gonna have to look to fund. But the cool thing is, look at how many farms now have tractors that are GPS driven that do what they need to, right? It's just, so it's not that they're afraid of technology. And those tractors cost a lot of money. Somehow they're making it happen because they know there's a benefit to it. So I believe that if you can prove that there's benefits to these, I believe even the local farmers will do that, but the stuff has to be funded. That's the trick.
Well, they have to do that.
Yep.
One more question? Anybody want to ask one more? Harry?
How adequate is the surveillance system for detecting emissions by companies? I read a long time ago that there was like 100 companies that produce most of the problem, and there might be satellite stuff that monitors. And is there any pressure being brought to bear on these carbon producers?
I think the technology and surveillance is not, and I'm not an expert in this particular area, but I don't think it's to the point where they can point out, corporation X or Y in terms of those measurements. But I think, through local measurements downstream and science, guesswork or whatever, and who's not putting the scrubbers in versus the ones who are and everything, I would guess if it is important enough, they would find that out. I know I read an article that in Southern California, there is a lot of leaks in the methane and petroleum pipelines that are through there that they can detect from low orbiting satellites and everything, and they've detected there's a lot more than we were thinking was being emitted from those. That has to be fixed. But that's money, and that as a company has to make that decision, because government can't go in and, right, unless you have regulations. So I think on some scale there is some of that, but I think if you're talking about the whole globe and all that kind of stuff, I don't think that we're there. Yeah, for sure.
Very good. Well, in around 1950, when Albert Einstein made his statement that I've quoted, people thought we'd never make it. People thought that dropping the bomb would be inevitable because we have the weapon and human beings tend to use the weapons that they have. But we haven't dropped it again. And a lot of not a lot, but a half a dozen or so, or 7 or 8 of the world's countries do have atom bombs. So we succeeded in not dropping it so far. And we may be able to succeed in dealing with this. Let's hope that we do, because we'll all be affected by this. I have a daughter who lives in Florida who was wiped out twice by hurricanes so far, and luckily, she bought a home in Wisconsin for the summer because the heat is so bad down there, southwestern Florida. She's going back tomorrow. Luckily, her home was not hit by Helena. She lives far enough south, and this hit mainly north, the Tampa area. But her insurance for housing is equal to her mortgage for housing, because the insurance companies do not want to touch Florida because of the hurricanes and because of the climate situation. It really is an emergency. And again, we want to thank our colleague Mike for bringing this knowledge to us and helping educate us on this issue. So let's hear it from Mike.
Let's end tonight with two short prayers. Mike said at the a way for us to continue on and not be overcome by giving up on these problems that right now don't have solutions, but knowing that if we can each continue and do things within our own world, in our own communities, and hopefully work on some of the things that Mike has said that on a larger scale, and especially considering, voting, because the solutions do need to be on a large scale. I'd like to just read parts from the Canticle of the Sun, and then Bob has a prayer that Pope Francis wrote at the time that the encyclical Laudato Si was released in 2015. Pope Francis took the name Francis because of St. Francis of Assisi, who is his inspiration, he said, and someone he feels very akin to. He talks about an ecological conversion that we all should go through in dealing, in approaching these problems, that we see us not apart from nature, but that nature is a part of all life, and we also are a part of it. So Francis of Assisi wrote, he was a poet, a friar, a mystic, and this Canticle of the Sun, he was born in 1181 and died in 1226, so many centuries ago. But it starts, Most High, all-powerful, all-good Lord, all praise is yours, all glory, all honor, and all blessing. To you alone, Most High, do they belong. No mortal lips are worthy to pronounce your name. Be praised, my Lord, through all your creatures, especially through my Lord, brother, Sun, who brings the day, and you give light through him. And he is beautiful and radiant in all his splendor. Of you, Most High, he bears the likeness. Be praised, my Lord, through Sister Moon and the stars and the heavens. You have made them bright, precious, and beautiful. Be praised, my Lord, through Brother Wind and Air, and clouds and storms and all the weather, through which you give your creatures sustenance. Be praised, my Lord, through Sister Water. She is very useful and humble and precious and pure. Be praised, my Lord, through Brother Fire, through whom you brighten the night. He is beautiful and cheerful and powerful and strong. Be praised, my Lord, through our sister Mother Earth, who feeds us and rules us and produces various fruits with colored flowers and herbs.
This is Francis writing in 2015, which is the year that Laudato Si came out, I believe. It's a prayer for the earth. All-powerful God, you are present in the whole universe and in the smallest of your creatures. You embrace with your tenderness all that exists. Pour out upon us the power of your love, that we may protect life and beauty. Amen.